Okay, so the concept of the mole fraction of a gas mixture is literally like a decimalized percentage by mole of how much of each gas is there in the mixture. So mole fractions should always add up to 1, okay? Just like decimalized percentages should always add up to 1. The key is to calculate them, you are going to need to calculate the number of moles of each gas. So there might be 2 gases in the mixture, like in this question, or there may be 3 or 4, whatever. You add together the number of moles of each individual gas to work out the total number of moles of gas in the mixture. So the mole fraction, we usually give the symbol X and then subscript of like whatever the gas is going to be the number of moles of that gas over the total number of moles in the mixture, so N total. So that is how you calculate. So for, let's just say it's N subscript A or something. Gas A, okay? So then for your mixture of gases, if we've got like gas A and gas B, your total number of moles of gas will be the number of moles of gas A plus the number of moles of gas B. Plus C plus D if there's more than one, okay? So this is super useful for using like Dalton's law of partial pressures, etc. So first thing we have to do is calculate the number of moles of our first gas, which is dinitrogen monoxide. So mass to moles, right? We can do that. So the molar mass of dinitrogen monoxide is 2 times 14.01 plus 15.9994 for the oxygen. So the molar mass is going to be 44.0123. So you're going to take that 2.17 grams, use the molar mass as a conversion factor. So 44.0123 grams for every 1 mole of N2O. So we can see that grams is going to cancel out, leave me with my moles of dinitrogen monoxide, which should shake out to be, let's see, 2.17 divided by 44.0123 is 0.049304. That'll do. Moles of N2O. Now, the number one thing I see people getting wrong with this question is because like you're used to like getting like a fractional number that's like less than 1, like 0 point something for a mole fraction. Sometimes people just stop after they got the number of moles of the species they're interested in, because like you've done some math. Are you done yet? So you've got to remember, you've got to calculate the total number of moles and then take the number of moles of the gas you're interested in divided by the total to get to the mole fraction. So don't just get a number and stop. Okay, so chlorine pentafluoride. Chlorine is 35.45 plus 5 times fluorine, which is like 18.999, blah, 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 blah. So we're going to convert 7 grams using the molar mass, which I got to be 130.438 grams for every 1 mole of chlorine pentafluoride. Would help if I could type today. So that is going to give me 7.02 divided by 130.438 gives me 0.0538. How many sig figs did I do? 2 more, 19 moles of ClF5. All right, so then to get our total number of moles, we've got to add together those individual number of moles. So my N total is 0.049304 plus 0.053819. It's going to give me a total of such suspense 0.049304 plus 0.053819 gives me a total of 0.103123 moles, okay, of mixture. So to get my mole fraction of my N2O, that's going to be my number of moles of N2O divided by my number of moles total. Okay, so it's kind of like a decimalized percentage, right? So that is going to be 0.049304 divided by 0.103123. And the mole fraction is unitless because you divide moles by moles. It's just going to be a ratio. 49304 divided by 0.103123 gives me 0.4783 3 sig figs is fine. All right, let's do the same for the mole fraction of the other thing, chlorine pentafluoride. So that'll be the number of moles of the chlorine pentafluoride divided by the number of moles in total. So that will be the 0.053819 divided by the 0.103123. Spoiler alert, these guys should add up to 1, okay? So we're expecting like 0.522, right? So 0.05 within sig figs, right? Depends how good the sig figs rounding is. All right, 0.522 to 3 sig figs. So if you want to do a quick check, 0.478 plus 0.522 will give me 1. So those are my mole fractions of each of those species. All right, so we're going to do more mole fractions when we do the next topic, which is calculating partial pressures in a mixture.